So Unit 2, Lesson 4. So we're factoring in the form of difference of squares. Look, okay? So we have difference of squares, but it's also going to be applying that same thing we were just doing just in the warm-up. It's putting in functions as the pattern as well. Okay? So just being able to sort here. Substitute if you want. All that stuff's fine. So it says expanded form of ax minus by and ax plus by. We know that or FOIL it. Since it's plus or minus, there won't be a middle. So that means, this is just kind of silly, but we'll do it for practice. A squared x squared minus b squared y squared is what you get. And then conversely, the factoring is that. So it just shows you the flip side of what we're doing today. Okay? The factored form is this when you FOIL it out. The FOILed out version factored is this. Go ahead and try those first three on your own there. See if you understand it already. Just see if you can do these. Okay. You can skip B if that scares you. Okay, you can skip B. We'll come to it. All right, what do we get for A? Who wants to share? What do we get for A? So go ahead, Nolan. Okay, good. Holds the pattern. A lot of it's square rooting, right? Square root of 9 is 3. Square root of 16 is 4. Okay. X squared square root is x, etc. Who wants to try C? Okay, go ahead and rope.
3xy.
Oh, you did this one.
Oh, yeah. Oh, sorry.
Yeah, it's okay. Let's go C. Let's go C.
So I got 4 brackets 6pq minus 1. No, I'm not doing the actual answer.
Is it minus R? Yeah,
The answer.
yeah. 4 6pq.
And then bracket 6pq plus 1.
Okay. Yeah. It just should be an R, not a 1. That's what you should have. That's all. Yeah.
Why would 12pq plus 4 be incorrect?
Good question. Okay. So the reason, and this came up earlier. Okay. So 144 and 4. So Riley says, why doesn't 12pq minus 2r 12pq plus 2r not correct? I wouldn't say it's not correct, but if you can see, 12 and 2 have what in common? 2. So if I pull a 2 out, 12 and 2 have what in common? 2 out. What's 2 times 2? 4. That means you could have took out a 4 to start with. Okay? So if we go back to our flow chart, you are supposed to GCF first every time. These are perfect squares, Riley, correct? But if you pull a 4 out, they still will be perfect squares. Okay, so
would the top be incorrect?
I would probably take off a half because it's not fully simplified. Okay, you want to take the 2's out as well. Now, if you get here and you take the 2's out, that's still fine. Okay? All right, so that's what's happening there. All right, I'll do B just because B, the problem is you can't do it right now. You have a y1 and a y3. Those aren't perfect squares. Okay, so we need to take a y out to start. And an x, yes, sorry, thank you. And an x. And a 3, yeah, all of that. 3x and a y. There we go. Okay, because 3 and 27 are perfect squares, x3 and x1 is not perfect, and y1, y3 is not. So good. So that gives me x squared minus. Now we're happy. Now we're happy. So we can. That's both. All that's perfect squares. There you go. Okay. Good, good. All right. So look at that next one. A little bit of reading. Okay. Good old pane of glass problems. Applying what you know. Okay, this one comes up often, so. All right. So pane of glass is a rectangle with an area of 49x squared minus 16y squared. So it's a rectangular area, meaning obviously that the side lengths are different. The length and width of the pane of glass can both be written in the form of ax plus by, where a and b are integers. Determine the appropriate values of a and b. Hint writes the form in x and y length of pane. Okay, so we essentially just got to factor this. We got to figure out, we know that area of a rectangle is length times width, and we know we can make this a two factors, L and W, essentially. Okay, so that's all perfect squares, that's all perfect squares. So it's going to be 7x plus 4y, we can call that our length, times 7x minus 4y, we can call that our width. It doesn't, but I typically make the length longer, so the plus one I make the length, but it doesn't matter actually. Because you can always turn the rectangle, right? And now your length and width is just flipped. Okay, and then so what I want you to say is, so if that's my length, we'll say 7x plus 4y feet is my length. 7x minus 4y feet is my width. All that's just doing is labeling, so if they give you values, then you can actually solve for x and y or plug in for x and y, depending on what they give you. Okay. Yeah. So it says, given that the length of the pane is double the width and the perimeter is 56, develop a strategy for determining the length and width of the pane. So what that means is, if the length of the pane is double the width, so that means that 7x plus 4y equals 2 times 7x minus 4y. Does that make sense? My length is 2 of my widths. Okay? And so if that's the case, we're doing perimeter now. You're doing perimeter rectangle, don't forget, you got your width, got your lengths. It's 2L plus 2W, right? Perimeter is 2L plus 2W. But we have it all in terms of W. Correct? Let's see. So length, this is length. This is width. They tell me in the problem here, the length of the pane is double the width. Whoops, excuse me. Okay, so we're just going to save this, the double one. You guys see that? 2 times my length plus 2 times my width equals the perimeter they gave me, 56. So what we have is, because how many variables are we missing? 2, right? So we have a system of equations. That's what we have. We have a system of equations. So we like to eliminate one so that we can isolate. Okay? That goes back to Math 10, system of an equation. Okay? So, yeah.
Where did we get why did we double the length now?
So we doubled the width, right? We're doubling the length because perimeter is 2 lengths and 2 widths. To find a perimeter of a rectangle, it's 2 lengths plus 2 widths. That's just standard formula for a rectangle's perimeter. So that's where that 2 came from. Okay, good. Anything else? Because now we're going to do the algebra piece. Okay. So what we're going to do first is we're going to go ahead and work with this. Okay? So we're going to just try to solve this as far as we can. So we know that 7x plus 4y equals 14x minus 8y. Okay, they will in a second. So, let me see here, hold on. Okay, so then we're going to simplify this one now, because we're setting up our systems. This is one of our systems. This is our second system, okay? So if I do this one, I get 14x plus 8y plus 14x minus 8y. And this one sets up nicely because your y's go away, right? And so my y's go away, giving me 28x equals 56. So now you can solve for x, x is 2. Divide by 28 to both sides. This one? Because we're going to plug the 2 over here now and solve for y. Because we can't plug in 2 here because why? Because they go away. Go ahead.
Why do we have the 2 in front of both when one is supposed to be double?
Okay, this is strictly perimeter formula. This is the double formula, the relationship between width and length. Okay, so Hunter asked, why do we have to double both of them? Again, remember, this is not part of what they're telling me for double. Okay? The part that says the pane is double the width, or the length of the pane is double the width, that is this right here. The length is 2 widths. But perimeter is always 2 lengths plus 2 widths. So we have 2 pieces of information. We have the length equals 2 widths, and then we have 2 lengths plus 2 widths equals 56. They're 2 separate equations. A perimeter, and then relating the width and the length. Now, once you were the perimeter here, when we simplify this one, we were fortunate enough to have the 8y's cancel. And so then we can solve for x, which is 2. We cannot plug the 2 into here and solve for y because the y's are going to go away. So that's why we need this other equation. Okay, so we come over here. 2 times 7 is 14. 14 times 2 is 28. And there we go. So when you solve for y here, we're going to minus the 4, minus the 28. So you get negative 14 equals negative 12y. And then we divide by negative 12. Yeah, 14. Negative 8 minus a negative, or minus 4. Simplify that. A little bit tricky, guys. Y is 7 over 6. This is definitely a hard problem. If you're struggling, that's okay. We can go over it again. But 7 over 6 is negative 14 over negative 12 simplified. 14 over 6, right? 2's. They both have 2 in common. All right, I'll take some questions. Okay, I'll walk you through it one more time. If you're just sitting there hoping that it'll come to you, that's probably not going to happen, so ask questions. Okay, so again, what we did was we have 2 equations. We have one equation of comparing the length and the width to each other, and we have one equation for the perimeter. Okay, that's in the problem. Again, length is 2 widths, so we have this equation, and then we have the perimeter equation. Using a system, we want to simplify the equations and solve for a single variable. So let's just pretend, what if the 8y's didn't cancel? What would we have tried to do next? No, good try. Remember the methods? You can solve by graphing, substitution, or elimination. Okay, those are the 3 methods from Math 10 that you use to solve systems. So what I'm saying is, you guys actually got lucky. They made this problem, actually, I know you probably don't think so, they made this problem easy for you because the y's went away. If the y's didn't go away, go back to Math 10, you have 3x minus 2y equals 8. This is made up. 6x plus 2y equals 9. Remember, you can add the equations. Those cancel. Your x, now you can solve for x. You have to do elimination if those 8y's didn't go away, or substitution. If you don't remember that, we'll have to do that then. You're supposed to remember that. Okay? All right. Okay, well, we will fix that. Right. So you would do that if the y's didn't cancel. So in this case, let me see here. So to do that, they both need to be like all on one side. So we would have moved this all over. And then we would have stacked them. So one would be equal to 0, one would be equal to 56. Yeah, and then we try to cancel stuff. Okay, I don't want to get into that because that's just going to go a little bit farther in the rabbit hole. It might make things worse for us right now. Okay, but my point is we got lucky that those canceled. If they didn't cancel, you're looking to do something like that. Now, to finish the problem, and I'll take a question. I think Joel might have had one. Somebody else had one maybe. It says determine the length and the width of the pane. So how can we find the length and width now? Well, we have values for x and y. Okay, here's my length, right? Here's my width. So we can now plug those in. So 7 times 2. Let's erase a little bit here. I'm going to erase this stuff up here, and we're going to put the answer up here. So length is 7 times 2 plus 4 times 7 over 6. So you can go ahead and calculate that. 14 plus, yep, 14 plus 20 over 6. Okay, it ends up simplifying to 18 and 1/3, or 18 and 2/3. That's what that simplifies to, 18.6 repeating. Okay, the width, same exact thing, but minus. And that ends up being 9 and 1/3, half of it, which makes sense, right? The width is half the length. They told us that. Okay. All right, that had a lot going on. I know, it's a hard one. We've got a couple examples, guys, and then we're done. Okay, now, guys, this is a perfect time. This is an absolute perfect time because I can tell right now maybe 20% of you understood that. Okay, you should be writing a question in your dash. I don't get why we had 2 equations. I don't get how we solve for x. I don't get. That's what you should be doing right now. Okay? If you're not going to ask a question out loud, you need to see it somewhere, and you need to ask me at some point. Because if not, it's just going to go on the wayside. I can't read your mind. I can't telepathically tell you that's what you want to know, right, Andrew? Okay? So please do that. Yeah. You guys got it? Thanks, Gabby. Over here? Yeah. The negative 12y. The negative 12y comes from I minus 4y over to the negative 8y. So negative 8 minus 4 is negative 12y. And then here, I subtracted 28 over here. That gave me negative 14. So that was me just algebra solving. Yep.
I'm confused where we got the 14 plus 4y equals 28 minus 8y.
14 plus, right here?
Yeah.
Okay, so this right here is 14 plus 4y is the, where are we at here? Oh, yeah. Yeah, so this is when we're putting in the x value now. So x is 2, 14. X is 2, 28. So yeah, thank you. Good job, Miller. Yeah. Sure. We're going to keep going, though. Okay, here we go. So here we go. So here's the forms we're focusing on today. You just did a little bit of the application that kind of gave the harder part first. But in general, here's the forms. Okay? We're looking for that same perfect square pattern. So we're looking for even exponents. Odd exponents can't be perfectly squared. So 6 can because 6 is 3 times 3. 8 can, 9 can't. Okay? When you see odds, then you have a problem. So can you GCF? Okay, so that's what you're thinking about. So when you look at these, let's go ahead and go through these. I'll do these ones. So 4, it's even, is 1 a perfect square? So we're good to go. So it's simply k squared minus 1, k squared plus 1. Why is it k squared? Because k squared times k squared is k4. Okay? B, 80, yuck. 5, yuck. Nope, don't like that. So let's take those out. Yeah. Not perfect square, that's gross. Okay, now we're good. 16 and 1. For a2 plus x2, 4a2 minus x2. Who sees it? Who wants to impress me? The one we just did. Yep. Who said that? Ah, boy, Gavin. This can go farther. Perfect square, perfect square, perfect square. Keep going. One more. plus sign one's always good, guys. You can't break down the plus sign one ever, right? Because it's not a difference of squares. This one is 2a minus x, 2a plus x. Now you're good. Yeah, you can't break down the plus one because it's not a difference of squares. Okay, this one is a difference of squares, right? So look for that minus. See if that minus can go again. Ooh, a lot of yuck. 2, no. 162, no. P5, no. Okay. So take out 2p. P4, Q4, 81, T4. Now we're good. Got all even exponents and an 81. Like that. Ooh, we're going to have to go twice again. 2p, p squared, q squared, minus 9t squared. P squared, q squared, minus plus 9t squared. This one can go again, right? P squared, q squared, 9. Everything in there is a perfect square, so that means you can go again. Okay, so let's write that final answer down here. I'll change colors here. 2p. This is where it gets crazy, guys. Take a deep breath. You'll be fine. Gotta challenge you sometime. Okay, that's just this one. I know it's small, but that's just this one right here. But this guy broke down to here. Okay. Yeah, Cal? Okay, because pluses aren't difference of squares, so pluses don't break down. Okay, why? Because, here's why, Cal. Because if I did, let's do s squared minus 9, right? And let's go x squared plus 9. So x squared minus 9 breaks down to x plus 3, x minus 3. Well, x times x squared, negative 3x, those cancel, right? What would you call that one? Would you call that, like, what would this factor down to? X plus 3, or, like, what would you think they would factor down to? Right, because the middle, like, a lot of people think this is x plus 3 squared, but it's not, right? Because x plus 3 squared has a 6x in there, that middle. This doesn't have middle terms, so that's not this. But difference of squares are the only ones that break down perfectly for factoring. Okay. Here you go. You guys want to see visually why? Here's visually why. You probably don't, but I'm going to show you anyway. Okay, so x squared plus 9. That's a parabola moved up 9. When we factor, we're finding the zeros. We're finding where this parabola goes through the x-axis. That's what we're doing right now. We're finding, so your regular parabola does this. We're finding those answers when you factor. Okay? X squared plus 9, that means I'm up here at 9, right? Does this. Is that crossing the x-axis? No, that's why it's not factorable, because it doesn't have any solutions. X squared minus 9. Where do you think those go through? Plus 3 minus 3, exactly. See the difference? So the x plus 3 is already too high to give you solutions. Okay? That's what's going on. All right, great. All right, guys, a little bit of the y there if you're a y person. Okay. Now this one, they're giving you the form. They're giving you the form. If you need to substitute this out for a letter, you can, but you don't have to. Okay, like for example, I know this is a plus b minus c, a minus b minus c. Right? A plus the thing, a minus the thing. All I have to do here is distribute this negative and I'm done. That's the first one. That's the second one. Okay, take a look. Okay, why don't you try B? I'll pause the video. Why don't you try B? Here we go.
Really?
Shh, rope. That was on the video. Okay, 2x minus 1 plus x plus y. 2x minus y minus x plus y. Okay, now just combine your like terms. 2x plus 1x, this one's 3x. Negative y plus y, gone. So 3x is your first term. Second one, 2x minus x is negative, or sorry, just positive x. Negative y minus y is negative 2y. That's all you should have left.
How do you get the 3x?
Yep. 3x. 2x plus 1x is 3x. Negative y plus positive y cancels. No y. Y goes away.
Oh, in that one.
Yeah. Yeah, this one. Anything else? I can see you guys better be doing this one, the homework assignment for sure. Yeah, just a second. Last example. Whoops. Last example. Okay, so this one's got a little bit of it all. Okay, it's got the binomials there for you. It has numbers in front. 36 and 49 can't be factored. Okay, like we can't pull anything out, but they are perfect squares, so that's fine. Okay, so 6x plus 5 minus 7x minus 8. That's my first piece. Stay with me. That's it. Now we have to just get like terms. Right? Square root 36, 6. X plus 5, 7, 8. Okay. So this is 6x plus 30 minus 7x plus 56. Then it's 6x plus 30 again, plus 7x minus 56. And now like terms. 6 minus 7, negative 1. 30 plus 56, 86. 6x and 7x, 13x. 30, negative 56. Okay, I'll stop there. I'll take a question. There is one little thing you can do at the end. Almost. Did anybody see that last little thing we can do? 13 here and here. So you can pull a 13 out, which makes this x minus 2. So that's it.
If we forgot that little extra step there, would it be
Probably wouldn't kill you for that one, no. Okay, but if they all have one, like if they both did, then that means you should have done it earlier, and I will for that. Okay, we'll stop there for the notes.